So guys, what we have here is we're asked to prove Pythagoras' theorem. We've been asked to prove again, just to rehash the whole thing, is that we want to prove that this green side squared equals this blue side squared plus this pink side squared. Hence Pythagoras' theorem of a right angle triangle. Now, we're at the stage where we had a big triangle ABC. We labelled all the angles in the triangle. Now, what I said earlier is that you pick the left triangle and the big triangle. Then you prove they're similar. You get the right triangle and the big triangle, and you also prove they're similar. So what we're going to have to do is this. We're going to have to write down two triangles. The first triangle is going to be ABD. You looking? ABD is this one here, and BDC is this one here. Now there's no real understanding thus far. There's just a procedure learnt off. Okay. Now what we're going to do next is we're going to that's a right angle triangle. That's ABD there, and the other side is B to D to C, and that is 3 and 4, and that is the big triangle is ABC, isn't it? Sorry, excuse me. The big triangle is ABC. I keep forgetting that. The left triangle and the big triangle. So go again. A to B to C. That one there. Okay. Now, what we have here is angle 1 on this triangle equals angle 1 on that triangle there. Any reason? Common angle. Do you understand that? There are common angles of both triangles. This is the triangle ABC. A to B is the angle 1. Do you understand? Yeah. So angle 1 is in both of them. The next one is the right angle. The right angle on this one equals the right angle on that one. And remember what I told you earlier on? When you prove that two angles are the same in both triangles, the third angle has to be the same. That means that angle 4 therefore has to be equal to, anybody? Angle, it's here, angle 2. Okay, now we're going to write that formally, okay? First of all, triangle ABD, triangle ABC. First of all, angle ADB equals angle ABC. Reason why? ADB is this one here, ABC is that one there. Why are they equal? Both 90-degree angles. Okay, next one. Why is angle 1 equal to the other angle 1? It's a common angle. It means the same angle is in both triangles. See these 3 dots? Do you know what that means in maths language? Therefore, it follows that angle 2, which is in ABD. See the way I have to, on the ABD side, I have to choose angles and sides that are in it, equals angle 4. And then hence ABD and triangle ABC are similar. Is that right? They're similar to each other. Now that that's done, what we're going to do next is we got to do Pythagoras' theorem there, okay? So, if you look at Pythagoras' theorem, what sides are in the one we want to prove? BC is there and AB is there. Which sides can we choose from this triangle that we need? We need AB, and what else do we need? We need AB, and from this triangle we could do it using BC. Okay, so let's use BC and AB from this triangle. So looking at these triangles very closely, now that we know that they're similar, I can actually rub that out now and just show you what we're actually doing here. Okay, I want you to choose AB, blue to green. Okay, blue to green is AB. What is AB equal to on the other triangle? Is equal to BC. No. AC. Look, AB is in between blue angle and green angle. Therefore, it's equivalent to AC on the other triangle. Remember we said that earlier about you match up what angles they're in between. Okay. Then we're going to pick AB on this triangle. And what's AB on this triangle? It's the blue to the black angle. Do you see that? So AB on this triangle is the same as what on the other triangle? Sorry? A to D. Cross multiply and you get AB squared. Do you know where I got the AB squared? AB multiplied by the other AB gives you AB squared, right? And then the other side is going to be AD multiplied by AC, which is AC by AD. Stop it there. That's the first piece of information you need. Okay? So that there is the first piece of information you need to make this work. So you have AB squared equals AC by AD. Okay, if you didn't get what I did before, I'm about to do it again, except for the other triangle. So this piece of information here, I'm just going to shrink it here and leave it in the corner, just wrapped up, because we're going to use it later on. Now, the next thing we have to do is we've already done the left big. Now we got to do the right triangle and the big triangle. The big triangle remains the same. However, the right triangle, what happens to that? What is the right triangle? The right triangle is BDC. Okay, guys. So the whole point was left big, the second point is right big. That's learned off by heart, not understood. Okay? So what I'm doing is the right one, right means the right triangle, the one that's to the right. Okay? That triangle is called B. It's called BDC. You happy enough with that? BDC. I put in the numbers I had before. I'll just put them in different colours. I'll call this one, actually I won't put them in different colours yet. That'll be 3, right angle, 4. Okay, using our knowledge, okay, what we're going to try and prove that the triangle BDC is similar to, anybody? ABC. Now, let's start off with what we know. Let's start off and get some easy marks, okay? We know that angle 4 is in both triangles, don't we? So we can say is angle 4 equals angle 4 reason. What's that word? Common angle. Angle 4 is it's an angle, okay? Now, are there any other angles that are obviously the same? The right angle. So we can say, what is the right angle for this one? BDC. Angle BDC is equal to, anybody? Angle ABC. Reason? 90-degree angle. Okay? Or about 90-degree angle. Now, if you prove that this green one equals this green one here, and you prove that I'll call that red now, okay? This one can be red. It's red one. It follows that the angle 3 has to be equal to angle 1. Why does angle 3 have to be equal to angle 1? Can anybody tell me? Why does angle 3 therefore have to be equal to angle 1? The other two angles are the same. Therefore, the three angles of a triangle must add to. I have to specify of a triangle. Add to 180 degrees. And what can you say then? Hence, BDC and what's the other one? ABC are similar. Okay, so remember your combo. Left one with the big one, prove they're similar. Right one with the big one, prove they're similar. Okay, and now once we prove they're similar, that's written down. Okay, so now we're going to see what happens after we prove they're similar to each other. Okay, after we prove they're similar to each other, we look at both of them. Are you understanding? We're just looking at the big triangle and the right triangle. We go back up the top and go, Well, oh wait, I rubbed out that part there from earlier. So I already found out what AB squared was, didn't I? And AB squared is this part here. It follows that I need to find out what BC squared is. So what you're going to do is choose BC on the left triangle. We're going to choose BC. Okay? And what is BC? Stop looking at that. What's BC the same as on a different triangle? On the second triangle. BC is in between red and green. What is it the same as on this triangle? AC. Perfect. Okay? Choose BC on this triangle here. Put BC underneath. What's BC the same as on the other triangle? It's equal to? BC is in between black right angle to green angle, which is DC. Thank you. And then finally cross multiply, and what happens? What happens when you cross multiply? You get BC squared equals AC DC, okay? Now, what we're going to get next, guys, is AB squared plus BC squared. Do you see that? The two of them added together. Do you see that? It's the same thing as AC AD plus AC AD plus AC DC. Okay? And what are we trying to prove again? AC squared equals BC plus AB squared, Pythagoras theorem. Now what can you take out of the two of these? What do they have in common? In the same way, if you had this, if you had xy plus xz, what could you take out? And you'd be left with x equals y plus z. That's what we're doing here. You see the way, we can take out AC, yeah? So we're going to be left with AC into anybody? What's left over? AD plus DC. Now, here's an interesting question for you. Using the original diagram, what is AD plus DC? Where is the original diagram? There it is there. AD takes you from here to here, plus DC takes you all the way from A to C. That means that AD plus DC is in fact AC. And now it's AC multiplied by AC, which is anybody? AC squared. So you get AB squared plus BC squared equals AC to B squared.